Hello and welcome to another calculus video. Today we're going to be talking about understanding the derivative. Now this is definitely going to be super important as the derivative takes about half of your year in calculus, and in general you're going to need to understand it in order to move forward with all the other topics. Now of course, as always, it's possible to just plug and chug, memorize the formulas and the rules and everything, but I find it's much easier to learn when you truly understand what's going on. So now we're going to talk about tangent lines. I'm going to just play this short video here, and keep in mind that this tangent line is very representative of what a derivative really means. What I want you to take away from here is as this little blue point drags across the graph of y equals sine of x, well, first of all, this line touches the graph at exactly one point. As you can see, sometimes it'll also touch later, like it'll touch somewhere around here, but we want to focus on right here. It touches exactly once, and the slope of this line is actually equal to the slope of sine of x. So of course, sine of x has a variable slope. Sometimes it's going up, sometimes it's going down. But if we zoom in, way in, we can find out that the derivative, or the slope, is actually going to be constant. This blue line is actually representing the slope of sine of x at a certain point. So let's move on to how can we actually calculate. So the derivative is going to be a function that's going to tell us the slope. So let's say we have some graph of f of x. The derivative we can write as f prime of x. So that's a prime, and it's just like a little apostrophe. And basically what happens is when we plug an x into this function, it's going to give us the slope out. So just by looking at this graph, if I look at f prime of 0, that's going to be when x equals 0, what's the slope of this function? As you can see, it's almost straight, but it's pointing down just a little bit. So I'm going to say f prime of 0 is about negative 0.1. What are some formulas that we can use to actually evaluate these derivatives? But first, we're just going to focus on understanding. Okay, so now let's talk about how can we figure out a formula for f prime of x. Well, the problem that we have here is that the only formula we know for slope, it contains 2 points. So we have y2 minus y1 over x2 minus x1. This gives us the slope of between 2 points. So you can use this to figure out the average slope over a general area of a function, but we want the slope at a specific point. So first I'm going to switch this to function notation. So what can we do to eliminate our second point? Currently we have 2 points, but we want to find the slope at one exact point. Well, what I'm going to suggest is that we try to move our second point directly to our first point. Now the problem with this is if x2 equals x1, that means f of x2 equals f of x1, so the top becomes 0, and x2 minus itself is also going to be 0. That's 0 over 0. We have a problem. So obviously our points cannot be exactly equal to each other. So what else can we do? Well, we know that they have to be right next to each other. And in fact, we can use calculus to say that we're going to make them infinitely close to each other. So the distance between our 2 points, this is x2 and x1, I don't know, we'll have our function. F of x2 is right here and f of x1 is right here. We're going to move x1 to x2 as close as we can using a limit, which is something we talked about in our previous videos. So now I'm going to write some notation out here. So we are going to denote f prime of x as a limit, and the letter that we're going to use here is h. That's just what's generally accepted because it represents horizontal distance. And so we're going to say, since we're trying to find the derivative at x, not at h, we're going to write f of x plus h. So that's f of x plus a tiny amount to the right, minus f of x, of course. And I'll give you a moment. Try to figure out for yourself what should go on the bottom of this quotient. Okay, that's right. So we have x plus h minus x. So on the bottom, it's going to be just h. Now, of course, if we immediately try to plug h equals 0 into this quotient, we're going to get, again, 0 over 0. So that's why we need to use limits and algebra in order to simplify this limit. So this is our general formula for f prime of x, but there's one other formula that we need to know. Now this formula is only helpful for finding the derivative at a specific point. So for this definition, we have f prime of x equals limit as h goes to 0 of f of x plus h minus f of x over h. This is going to spit out some function of x. So then what we can do is plug in any x and find the derivative at that point. But for more complex functions, we might not be able to do this. So we're going to have another formula for f prime, but instead this is f prime of a. So this is something generally we're just going to plug in a without evaluating the limit beforehand. So now keep in mind that it's important to know both of these definitions. They both will come up during calculus. So this is going to be limit as x goes to a, f of x minus f of a over x minus a. So these are our two formulas for derivatives, and this one is definitely more important. This is called a difference quotient, and that's what we'll talk about in our next video. Anyway, I hope you found this short video helpful, and as always, remember it's better to understand what you're doing and what everything means than to just memorize and plug things in. So I hope this video helped you, and I'll see you in the next one.